Alright, we're on to problem number 2. We have given AB is parallel to DE. You can mark this several ways, but I just do that. Also, another given, we have C is the midpoint of segment AE. So right here is the midpoint, and that means that this is congruent to this. So AC is congruent to CE because C is the midpoint, separating them into two congruent segments. What else do we have? Now we have ACB is congruent to DCB or DCE because they are congruent. They're not. I'm sorry, because they're congruent because they're vertical angles. Also, angle E, is congruent to angle A because of alternate interior angles, as well as B is congruent to angle D because of alternate interior angles. And you're left with angle, side, angle for the triangles. What does that mean, though? It means that triangle ABC is congruent to triangle DEC because you have this angle here because of alternate interior, this because of C being the midpoint, creating two congruent segments, and this angle because vertical angles. Okay, but that's not what we're trying to prove. What we're trying to prove is AB is congruent to DE. And to prove that, we need the CP-CTC, or congruent CP-CTC. Oh my god. Or congruent, I'm sorry. Corresponding parts of congruent triangles are congruent. There we go. So and what that means is, since we're trying to prove AB right here is congruent to DE right here, that means that since corresponding parts of congruent triangles are congruent, it means that since this corresponds to this on this triangle, so AB corresponds to DE, and they're congruent because of angle side angle, this automatically makes these two parts congruent. So you can mark that like this. That is proof number 2.